Most users today get their power from the macrogrid, commonly referred to as the utility. The macrogrid receives its AC power input from large decentralized power stations. A microgrid, however, is a group of interconnected loads and distributed energy resources, or DER, within clearly defined electrical boundaries that act as a single controllable entity with respect to the macrogrid. A microgrid has power generation independent of the macrogrid. There are three types of microgrids: remote, macrogrid connected, and networked. Remote microgrids, also referred to as off-grid microgrids, are physically remote and isolated from the macrogrid, and said to be operating in island mode. An advantage of microgrids over the macrogrid include no infrastructure costs to erect transmission lines to remote macrogrid. In many cases, renewables such as wind and solar are less expensive solutions. They meet environmentally sustainable distributed energy requirements, and they have a greater reliability than the aging macrogrid network. Grid-connected microgrids are the second type of microgrid system, where there is the ability to switch to the macrogrid either to take energy from or input to, when the microgrid is connected to both the extra high voltage and high voltage sections of the macrogrid. Connection of the two grids is via a switching mechanism at the point of common coupling, enabling the microgrid to be switched from island mode to grid-connected mode. Having the ability to connect the macrogrid addresses issues such as capacity, power quality, whereas switching to island mode can isolate connected loads from voltage and frequency issues occurring on the macrogrid. When serving a relatively small geographic area, grid-connected microgrids demonstrate economic viability for educational campuses, medical complexes, public safety, military bases, agricultural farms, commercial buildings, and industrial facilities. The third type of microgrid is a network grid, also known as a nested grid, and employs several microgrid systems. Nested microgrids connected to the macrogrid can supply power to a wider geographic area. For example, a residential microgrid system could be linked to a smart city system. Supervisory controls operate the network of microgrids within the system. Another microgrid could be supplying an industrial area, and another microgrid could be powering a data center. The nest of microgrids would also be connected to the macrogrid. The controls will track demand and switch microgrids within the system from the macrogrid into island mode as required, and switch to the macrogrid as required to meet load demand. Smart cities can take advantage of a community of microgrids by monitoring the system load with switching controls sharing the connected load to the nested microgrids and any connection to the macrogrid. As weather and other security-related issues affect the macrogrid increasingly, power-critical facilities are adopting microgrids to meet their power needs. Such applications include data centers, smart cities, industrial sites, or neighborhoods. Many cities are showing interest in power systems that can better integrate a variety of power sources, especially renewable, battery backup, and CHP systems, to serve multiple users and at the same time address environmental concerns and more security than the macrogrid can provide. Microgrids benefit many parties like utility operators. With local energy controls, they can balance uncontrollable renewable energy sources such as wind and solar, with controllable diesel and gas generator power. Batteries provide energy storage to balance power usage and production. The environment is a huge beneficiary, principally from zero-emission power sources and a reduction in power losses through transmission lines within macrogrid systems. User power security is greatly enhanced, and users don't have to rely on an aging macrogrid with its exposure to weather, overload brownouts, cyber attacks, and the reliance on one power source. Microgrids are a doable solution to an aging macrogrid with all its inherent weaknesses and an opportunity to utilize efficient renewable energy in step with established energy solutions such as engine generator systems.